Welcome to the second video in the series on assessment. We will be covering 23 quick formative assessments. Some you can use right before you begin a lesson, some during a lesson, some you could use as a pre and post check, and finally there are ones you can use once you complete a lesson. The objectives for this video are that out of the 23 ideas provided, you should be able to describe at least 10 formative assessments. And also, out of the 23 ideas provided, you will use at least 4 in your science lessons. Would like to see you utilize a variety of formative assessments. So we will begin by reviewing 4 ideas that will help you find out what your students know or don't know before you begin a lesson or unit. Commit and Toss uses the prompts from the Uncovering books, or what I call the Misconception books, and we're going to be looking at these on Monday. Basically, in these books, there are prompts to have the students complete. Let me give you a couple of examples. So here is one which is focused on light, and the students check which types of objects and materials can reflect light, and they do a little bit of explaining their thinking. Here's another one. Is it an animal? They mark whether it's an animal or not, explain their thinking. So what they do is they fill out this prompt, they scrunch it up, and they toss it across the classroom, and you toss them about 2 or 3 times so that it ends up at the foot of another classmate who did not write the prompt. And they open it up, and so anonymously you're discussing what people's thinking are. Now, I know that sometimes students will know each other's handwriting, but it's supposed to be a fun activity in which you then discuss what are people's thoughts, what is an animal, what reflects light, and they're thinking about that before you start a lesson so you can start looking at misconceptions. Another one is concept maps. It's some of the same premises. You're gauging what the students know, what if they have any misconceptions. And these are cartoons with 3 children saying something, or in this one there's 4, in which they're making a comment about some kind of phenomena. So here it is with the snowman. Don't put the coat on the snowman, it will melt him. I don't think the coat will make any difference. And here the third one is saying, I think we'll keep him cold and stop him melting. And so what you do is you have a discussion in which you ask the students which child in the cartoon do you feel is correct. And again, what this sort of gauges for you is, do they have any misconceptions about the concept you're about to be teaching? Card sorts. Very similar in terms of gauging misinformation to help adjust your instruction to emphasize concepts that are erroneous. So you have a mix of cards, some true examples, some false, not examples about a topic. Students sort into true examples, false, not example piles, and it can be used again, as I mentioned, to find out what students already know or to assess learning. And here's an example. You can make your own, or this is actually from one of the Uncovering books. You could have used the same one that we looked earlier on animals, but make it into a card sort so there's something that they're doing at least. Seems like a no-brainer, but you can conduct informal student interviews, whether at recess, in the hall, on the playground. Talk to students and listen to them. For instance, say, I was wondering if you could help me think through some ideas about science. I have been talking with several people who seem to have different ideas, and I'm curious as to what you think. It's almost like taking one of those concept maps, cartoons, and turning it into a conversation. So don't forget to use these informal student interviews. Now we're going to be turning to 9 ideas you can use during the lesson you are teaching. Fist to 5, you probably know, you just fist if you have your understanding is clearly no understanding, all the way to 5, in which you're showing that you have strong understanding of whatever is being taught. A very quick way to do that. Traffic, like cards or cups or dots, can also be used, in which the red indicates help, I or we don't get it. Yellow, we understand most of it, but I or the group could use a little help. And green is that you're understanding very well. Generally, cards are usually used with individual students, that they would hold up a red card, a yellow card, or a green card. Cups are used with groups, and the dots with students to self-assess their work and place in the margins of their work. So again, to give you some sense of how they're feeling, how comfortable they're feeling with the content. Guided reciprocal peer questioning is a rendition of think, pair, share, but you're actually giving them questions to think, pair, share with. I'm not going to read all these questions. I'm going to be putting a PDF of this PowerPoint into the Blackboard site, and you will be able to access them then. But it's giving them a specific question that they can ask that they then talk to a partner about. 10.2. What we're trying to do with 10.2 is you change this to this. Basically, you shouldn't be talking to the students or at the students more than 10 minutes before you have them engage in a question or an activity of some sort. And it can be a 2-minute activity or a 2-minute question answer time, but never, lecture or talk at them for more than 10 minutes. Paint the picture is just in which students visually depict their thinking about an idea without using any annotations, although they did with the Potassium Man a little bit, representing it to someone else to understand their ideas. They then share with a partner with you circulating, listening to their explanations. You do not comment on their artistic ability, since that is not important. You're just checking on understanding. Journals can be used in many ways, but they can check how a child is thinking or feeling about science. So you do not grade it, but it is essential that you read and respond to the journal writing. There's a tip that try to only respond, if you're doing journaling in science, only respond to about 5 journals a night, and allow students to flag the entries they want you to attend to and respond. So what would these prompts look like for them to write in their journal? So ideas would be to provide a clear, well-defined purpose for writing in their journals, who the audience is. Are they writing to you, the teacher, to a friend, to a student in the lower grade, or you could even make it fun and have them write to a Martian, and you're giving them a definite time frame within which to write. Here are some suggestions. I'll just highlight a couple of them. I think science is important or not important because, and they have to answer that thing. Explain to a student in grade X what you learned today about adaptations, or substituting the topic that you're looking at. So again, I'm going to be providing a PDF of this PowerPoint up in the Blackboard, and you'll be able to look at these suggestions in depth. Journals for K1 children, what you can do is use the large chart, the giant journal. The teacher uses a flip chart and students respond to a prompt, and the teacher writes their ideas, adding the child's name and drawings when appropriate. Again, trying to attain what they're understanding, what level they're at. I think we think uses a 2-column sheet of paper, as you can see, to record their own individual ideas. The I think is before there's a group discussion, and then the we think is following a group discussion to see whether they've changed their thinking at all. Or you could say, I used to think, but now I know. And so looking again, prior to learning, what they now learn, or what I learned, and you could also have them discuss how they learned it. Misconception is a statement about something that reflects a commonly held idea, but it is incorrect. You could use this from any of those uncovering books that we've talked about already. Students are asked to analyze the statement, describe why people believe it is true, and describe what one could do to help someone change his or her misconception in favor of a scientific idea, and finally, reflect on their own ideas in relation to the statement. If you remember one of the movies that we saw in the beginning about the log and what causes trees to be large, this would really be helpful to try to attack those misconceptions that students tend to have. No hands questioning, I call it volleying. It's basically the teacher poses a question, practices wait time of 3 seconds, Mississippi 1, Mississippi 2, Mississippi 3, that you say to yourself, and calls on students randomly, then volleys by saying, what do you think would happen if this happened, if you changed this one thing? What do others think about someone's idea? Would someone like to add to someone's idea or share a different thought? So you're actually mulling around and you're not just asking a question, student answer, ask another question, student answering. So you're fostering a discussion and getting a sense of whether other people understand the concept. So before and after instruction is basically a pre and post checking to gauge if your instruction hit the mark. This is something that has been used a lot, actually in research, but also in K through 12 classrooms. Is basically annotated student drawings, what they think before and what they think after. And this is a draw a scientist activity in which they draw a scientist before they may talk about all the different scientists in the world or in the area, and then how do they depict a scientist afterwards. You could do that with any concept. Here is a concept map in which you start like with a concept such as monarch butterfly and say, put down anything you know about monarch butterflies and connect it with arrows, which we call links, so that you can, so a monarch butterfly starts as a caterpillar. Okay, so you do this beforehand and then they revisit afterwards and they do a post-concept map. And what you're hoping is that it's much more sophisticated because they have learned about so many more things about, for this example, monarch butterflies. First word, last word is you take a word such as photosynthesis, and what they do is they start something that talks about photosynthesis using the P letter, the H letter, the O, T, O, S, and so forth. What they know before you start your unit on photosynthesis. And then at the end, you have them do the same thing. Again, put photosynthesis down the end of the paper, and then what do they have to say something about photosynthesis that starts with a P, an H, or an O, or T, etc. Again, you're looking at the pre and after the post check to see if they have increased their understanding. It's just a fun thing to do. True-false justification statements is that you generate some true-false statements. You have them take this quick quiz. You tell them it's not graded or whatsoever. And then after the end of the lesson or at the end of the unit, they go back and redo the true-false quiz and see if they are getting more correct answers. Again, you're not grading it summatively. You're just checking to see, have they changed in their thinking? Are they more correct than what they were at the beginning? KWL is when you start a unit, you can have them list what they know about a topic, what they want to know about a topic, and then at the end, you go back and you say, what have I learned? KWF is similar, what I know, this is what I wonder about, and this is what I found out about the content. OWL is this is what I observed, this is what I wonder about those observations, and this is what I've learned. POE stands for this is what I predict, this is what I observed, this is how I can explain it. So these are just fun ways to then, again, gauging their understanding. Sticky bars are when students are presented with a multiple choice science question and they place their answer on a post-it note that forms a bar graph right here. So it's A, B, C, D, E. They have those 5 possibilities and they put post-it notes in terms of the answer that they feel is correct. They then return to the bar graph and they can move their post-it note or their sticky bar over to another choice if they feel that they've learned and they have corrected maybe something that they thought they knew that they didn't know. So now this section will review 4 ideas you can use as you close your lesson. Here's a slide that looks at the Freyer model. This is when you really are getting them to learn different definitions or different terms or vocabulary. So you have a worksheet in which they put down the definition, the characteristics of whatever that is, and then some examples and non-examples. This has been found to really help them in terms of learning different vocabulary. Muddiest point is in which students are asked to take a few minutes to jot down what the most difficult or confusing part of a lesson was for them. You get to look at it after the class, and you can start the next lesson trying to clarify anything that was muddy. POMS is point of most significance, in which students are asked to identify the most significant learning or idea they gained from a lesson. And this is how you can check to see, did they learn, or what they learned that was most significant in their mind, was it what they should have learned in terms of what was most significant? 3-2-1 is a structured way for students to reflect on their learning. And this is one example. Basically, 3 prompts are given. The first asks for three responses, the second asks for 2 responses, and the one asks for 1. And this is an example. 3 key ideas I will remember, 2 things I am still struggling with, and 1 thing that will help me tomorrow. So this is the end of video 2. I know it was a little long, but we had 23 ideas to share with you. But hopefully quiz yourself and you will find, can you recall at least 10 formative assessments? Can you identify at least 4 that you will definitely implement in your science lessons? Because again, I would like to see a variety of formative assessments that are used in your instruction. Take care.